So here's another Tipper's problem. This is very similar to what you are going to see on the AP exam. In this problem, it tells us some information what the people think about this problem. So the first one, it says at the bottom of the swing she'll be moving exactly horizontal. Okay, I agree with that. So that would be moving this direction. That's the velocity. Since she is not moving vertically at that instant, the vertical forces cancel. Right? Now, moving has nothing to do with it. It's all based off of the acceleration. So is the velocity changing? Right? Here we can clearly see it's always changing direction because it's in a circle. So again, we know that the acceleration in a circle is to the center. So I am accelerating, so it cannot be that the tension equals the weight because there's an acceleration. The next one, just looking at the vectors, the change in velocity is upward between A and B, so that this is the direction of the acceleration and also the net force. To get a net force pointing upward, tension would have to be greater. So let's see what we agree with here. Let's see if we can prove this change in velocity. Well, we do V final, so that's at B, minus V at A. So what I can do here is put in A on the top of B, but make it go negative. So here I can see this vector is that way, this is A, and so my resultant VF minus VI is the change in velocity. Here you can see that is pointing to the center at this location. So if that's the forces on the object, tension does have to be greater than Y. So his seems good. But these aren't just two forces acting on the bottom. Since she's moving in a circle, there's also a centripetal force. Right? This is the one that we told you there's no such thing as a centripetal force. That is just a direction. So I agree with Brian. Okay? Based off of that again, the acceleration is to the center. So F net to center. The bigger force has to be whatever's to the center. The bigger force has to be tension.